Hi guys, welcome back to Worms Maths Academy. Today we're going to be looking at applications of integration. We're looking at basically kinematics, which we do in specialist maths. I'm still not 100% sure whether this is part of the course or not. Like it's sort of a bit debatable, but we'll go through it anyway. And that way, if it does crop up, you've always worked out how to do it. The first thing I need to let you know is if they give you something like x of t, which is our displacement function. So it tells us where we are at any point in time relative to an origin. If we want our velocity from our displacement, we know that speed is distance over time. Well, velocity is displacement over time. So that would be average velocity. That would be your change in displacement over your change in time. That means changing. So if I wanted to work out average velocity, we've got to use our displacement. But if we want our instantaneous velocity, v of t, is our instantaneous change in x over our change in time, dx dt. That's our velocity. So that's at any point in time we can get our velocity. It will be either positive or negative because velocity is what's known as a vector, so it can have direction. Whereas if I said to you, what's the speed at a specific time? That's the magnitude of that. However, we don't need to do this for method. That's why I'm saying this is a bit, I don't think it's supposed to be covered in depth, but how much depth I don't actually know, so it's a bit frustrating. Okay, if we've got our velocity and we want to get our acceleration, well, our acceleration is our rate of change of our velocity. So it is dv dt. Or you can say d squared x dt squared, which means that I've derived my displacement twice to get to my acceleration. So these are all functions of time. One is our displacement, how far we are from a single point, from a starting point. Our velocity is basically which direction we're going and at what rate we're going at. And then our acceleration is how quickly our velocity is changing. So I'm just going to create a little table. So x of t is displacement. If we derive that, we get v of t, which is our velocity. And if we derive that, dv dt, that gives us AAT, which is our acceleration. Conversely, if I want to go from acceleration to velocity, we can integrate acceleration and we'll get our velocity. And then if I want to go from my velocity to my displacement, we can integrate our velocity and we will get back to our displacement. Like with these, you're always going to have an initial condition. So if they give you an initial condition, you can work out what the values of C are. Generally, it'll be written in the question, but it won't be pointed out to you like some things are. You've got to read the question and break it down. So let's have a look. A body starts from 0. So it starts at the origin, so that means when time equals 0, my displacement is equal to 0. Moves in a straight line, so that means it's going right or left. If it's positive, it's going to the right. If it's negative, it's going to the left. So this is O, our origin, positive and negative. After t seconds, its velocity is given by v is 2t minus 4. So that's how we get our velocity at any time, but time has to be positive or 0. It says, find its position x in terms of t. So we know x of t is our integral of 2t minus 4 dt, because x of t is my integral of velocity. So in this case here, we get x of t is equal to t squared. When I integrate 2t, I get t squared minus 4t plus c. And we know when t equals 0, x equals 0. So therefore 0 is equal to 0 minus 0 plus c. So c equals 0. Therefore our displacement, or our position at any time, is x of t is equal to t squared minus 4t. Now, if we know that our position is given by x of t, and we want to know its position after 3 seconds, well, we say x of 3 is equal to, wherever we've got a t, we replace it with a 3, so 3 squared minus 4 times 3, 9 minus 12, which is negative 3 centimeters, or 3 centimeters to the left, because remember it's negative, of the origin. Okay, now it says the average velocity in the first 3 seconds. So we've got to get our starting position, x of 0, which is 0, so we've got the point 0, 0, and we know x of 3 is negative 3. So we get 3, negative 3. Our average velocity is just our gradient between those 2 points. So even though it says velocity, we're not going to use the velocity function, because your average velocity is your change in displacement, so your change in x over your change in t. So we start at 0, that's our end. Our end point is 3, negative 3. So my end point is negative 3 minus my start point, which is 0, over my end time, which is 3, minus my starting time, which is 0. So we get negative 1 centimeter per second. So our average velocity is negative 1 centimeter a second, and that makes sense because we know it starts at the origin, 0, 0, and after 3 seconds, we're at the point negative 3 centimeters. So if we go 1 centimeter, 2 centimeters, 3 centimeters, if we go at 1 centimeter a second, after 3 seconds, we're going to be 3 centimeters to the left. It's negative because we're going to the left. If we're going to the right, it would be positive. So velocity has direction. It tells you whether you're going left or right. Now the next thing it says is what's the distance traveled? So here, if I go from the origin to negative 3, that's my displacement after 3 seconds. If I want to know what my distance is, we've got to work out if the particle has gone up and turned around. Because my distance, everything is positive, so we count that as positive, and going back we count that as positive as well. When you turn around, v of t equals 0 if you stop or turn. So we know what v of t is. It's 2t minus 4. If we let that equal 0, we get 2t equals 4t equals 2. So at 2 seconds, this particle is turned around. So what we do is we want to work out what the distance is. So we know it started at the origin, because when t equals 0, that equals 0. At 2 seconds, x of 2, if I put 2 into that function, we get 4 minus 8, which is negative 4. So after 2 seconds, we're at negative 4. And then after 3 seconds, so another second, we're at negative 3. So if I was to walk from here to here, and then back to here, to go from the origin to negative 4, well, that distance is 4 centimeters, well, meters, but it's in centimeters. So it's 4 centimeters back to here, and then it's 1 centimeter here. So my distance is 5 centimeters. That's how far I've traveled. If I ask you for displacement, your displacement is how far you are from where you started. So how far am I from where I started? I'm negative 3 to the left. So that's my displacement. So your distance is always going to be greater than or equal to your displacement. It can never be more than, so it's always going to be less than or equal to your displacement. It can never be more than. So if I want to work out the average speed, so we've got its average velocity, which is negative 1 centimeter a second. Our average speed is our distance, average speed. Forgot to write speed. That's our distance over time. Our speed is always positive, doesn't have direction. Our distance is 5 centimeters, and we did that over the first 3 seconds. So it is 5 on 3 centimeters per second, or 1 2/3 centimeters per second. So if we look at the size of our speed, that's 1 2/3 centimeters a second. Well, this is negative 1 centimeter a second. It's 1 2/3 because we've traveled all the way back to negative 4 and then back to negative 3. So the distance we've traveled is 5 centimeters over 3 seconds, which is 1 2/3 centimeters a second. Okay, a particle starts from rest 3 meters from a fixed point. So we know x of 0 is equal to 3. That's what I meant before by saying you've got to read the question and state the information so that you don't stuff it up, because it gives you what the initial conditions are. It starts from rest. So we know that our velocity is 0 when time equals 0. Moves in a straight line with an acceleration of a of t equals 6t plus 8. Find its position and velocity. So we know if we've got a of t, if we want to get v of t, that's the integral of a of t dt, which is 6t plus 8 dt, which is 3t squared plus 8t plus c. When t equals 0, v equals 0, and that's because it starts from rest. So therefore, because it's a polynomial, they're just going to equal 0, so c must equal 0. So we know that v of t, my velocity, is given by 3t squared plus 8t plus 0. Next, we want to find our position, and we know x of t is the integral of v of t dt. So that all stems from the table that I wrote. So x of t becomes v of t becomes a of t dx dt dv dt And likewise, if I integrate a of t, we get v of t, and if I integrate v of t, we get x of t. Okay, so x of t is the integral of 3t squared plus 8t dt. When I integrate 3t squared, I get t cubed plus 8t to the 2 on 2, which is 4t to the 2, plus, now you can't use c because you've already used it, so let's say plus d. When t equals 0, x is equal to 3. That's from 3 meters from a fixed point. So say 3 is equal to 0 cubed plus 4 times 0 squared plus d. D is 3. Therefore, x of t is t cubed plus 4t squared plus 3. So there's our two functions, v of t and x of t. Okay, so they're looking at particles traveling in a straight line. Now we're going to look at particles that are projected, or rocks or something that's been projected up into the air. And in this case, the thing that accelerates something, like a pen, if you throw it up in the air, the thing that's accelerating it is gravity back into the earth. So here, a stone is projected vertically upward from the top of a building 20 meters high with an initial velocity of 15 meters a second. So here's my building. Let's go to window. A good diagram always helps do the question. So I'm going to say here's my catapult. It's projected upwards and it comes back down. This is 20 meters off the ground. When it takes off, its speed, v, is equal to 15 meters per second. And we've got a force going on it, that's acceleration, which is, now usually say negative 9.8, but for this question, let's say it's negative 10 meters per second. That's what physics teachers do, because it's much easier to use negative 10 than it is negative 9.8. But we'll assume with this question we don't have a calculator, so we use negative 10. Okay, the stone is projected vertically upwards, 20 meters high, so we know x of 0 is 20, and here we know v of 0 is 15. Find the time taken for the stone to reach its maximum height. So there's its maximum height. We've got our acceleration. Our acceleration is negative 10 meters per second squared because that's gravity coming into the ground. So our velocity is given by the integral of negative 10 meters per second squared dt, which is negative 10 plus c, negative 10t plus c. We know when t equals 0, v equals 15. So v of t is equal to negative 10t plus 15. Max height will occur when velocity is equal to 0, because when you throw it up, it's going to go 10 meters a second, it's going to slow down, slow down, slow down, until it gets to here, and then the velocity changes direction. So when that equals 0, negative 10t plus 15 equals 0. So we get 10t is equal to 15. T is equal to 1.5 seconds. So that's our answer to the first bit. When does it reach its maximum height? At 1.5 seconds. Okay, find the maximum height reached by the stone. So we've got our velocity, which is negative 10t plus 15. Now we can say our displacement is the integral of negative 10t plus 15 dt, which is negative 5t squared plus 15t plus d. And we know when t is 0, my height is 20, so d equals 20. So x of t is negative 5t squared plus 15t plus 20. And then we want to find x of 1.5, which is 3 on 2. So negative 5 times 9 on 4 plus 15 times 3 on 2 plus 20. Okay, negative 45 on 4 plus, that's going to be 45 on 2, which is 90 on 4, and then plus 80 on 4, which is 125 on 4 meters. That's the max height. How many 4s go into that? 25, 31 and a quarter. So that's the maximum height, is 31 and a quarter meters. Find the time taken for the stone to reach the ground. So x of t will equal 0, because there it's at 20 meters, but when it gets down to the ground, the height, which is x of t, will equal 0. So we've got negative 5t squared plus 15t plus 20 is 0. Divide through by negative 5, t squared minus 3t plus 4, no, minus 4, equals 0. T plus 1, t minus 4 is 0. So t equals negative 1 or 4. Therefore, t equals 4 as t is greater than 0. So at 4 seconds, that's when the stone hits the ground. Now the velocity of the stone, well, you know when it's accelerating, when it takes off here, at 20 meters, it's at 15 meters a second. So because of symmetry, when it's over here, that's going to be at negative 15 meters a second. So it's got to be faster than that because it's got acceleration, making it go faster towards the ground. So the velocity of the stone, so we want v of 4. So we sub that into our velocity, which is negative 10 times 4 plus 15, negative 40 plus 15, negative 25 meters per second. So that's the speed. When it hits the ground, it's going at negative 25 meters a second. Does that make sense? It takes 1.5 seconds to get up to here. So it's going to take another 1.5 seconds to get back down to here because it's symmetrical. So that's 3 seconds. And then it takes another second to drop right down. If here it's at negative 15 meters a second and we're accelerating at negative 10 meters per second squared, if it's at negative 15, if we accelerate negative 10 meters a second squared, in another second we should be at negative 25 meters a second, which is what we are. Hopefully it makes sense. Sorry, it's a bit complex because it's more of a specialist maths topic than it is a methods topic. It's kinematics in specialist, and obviously in that we do a lot more complex equations, but the concept is still the same. So possibly need to know it, not 100% sure if you do or not, but hopefully you understand what I've just gone through. If not, I wouldn't stress too much. I've never really seen it on a methods exam. I don't think I have seen it at all. So anyway, good luck with that, and I'll see you soon. Bye.